Welcome to The Microscopists, a bite-sized bio podcast. Hosted by Peter O'Toole, sponsored by Zeiss Microscopy. Today on The Microscopists.
Hi, I'm Peter O'Toole, and today I'm talking with Harry Schroff of the NIH about moving from startups into academia.
What finally convinced me was a conversation I had with somebody who said, why don't you just try it, and see.
Obstacles to success?
I think you're hitting on one of the most difficult things we have to deal with in academic science.
And the challenges of raising a young family.
I can never replace the mom part of my wife, right? But I try when I'm home.
All in this episode of The Microscopist. Hi, I'm Peter O'Toole, and today with me is Harry Schroff from Bethesda, the NIH over there. Harry, hiya.
Hi, great to see you. Thanks for letting me do this.
Pleasure, and all the more exciting because I hadn't realised when we set this up, actually, well, I guess we wouldn't have realised that you just released a publication in Nature Biotechnology.
Yeah, we're very happy about that. That was a long time coming, so it's nice to see that come out this month. Yeah.
So that was on. Actually, the title is quite wordy.
Mm-hmm.
I read through it, so it's actually multifaceted. There's a couple of different new developments within that one publication, isn't there? Looking at the CPU, the algorithm, software, and also the dual view approach.
Yeah. It was a lot of stuff kind of packed into that article. So it's fairly dense, and I guess the overarching theme is trying to make some of the processing that we do faster, because that certainly bottlenecks our lab, and we figured it probably bottlenecks many other labs as well. Sort of after you get the microscope image, you need to post-process it. How do you do that quickly, or how can you do it more quickly? And so that's what that article is kind of broadly about.
So how many years effort do you think was behind that publication?
We first started sort of getting down into that maybe 5 years ago, and then sort of picked up steam after that. But the first inklings were probably in 2015, and then there's the whole sort of year-long saga of getting it published, right? Which also takes time, sort of sending it out, getting the reviews back, which is kind of lengthy. So yeah, years of time.
And how many staff years? So how many team years, PhDs, postdocs? Innumerable
staff years, because they're the sort of core group of people in my lab, and then we worked fairly closely with other researchers in China and at University of Chicago, and then there were all of the biologists that we enlisted to help with sample prep. So many staff years. It was really a collaborative effort, which we're just sort of lucky that that's becoming in some ways easier and easier, I think, to do. So
that it was interesting. It's amazing the number of years that it can take to get a publication out, and the cost of science is huge because of all that effort and the team efforts that are needed behind it. It was interesting you said you recruited loads of biologists, because I guess, would you count yourself or class yourself as a biologist?
I'm kind of uncomfortable with labels, but I think most people would say that I'm not a biologist. I love biology and being able to contribute to biology with some of the tools that we built, and we have a couple of biological projects in our lab, but I guess I wouldn't characterize myself as a biologist. So we benefit greatly from collaborating with bona fide biologists.
So you started out, if I remember correctly, your undergraduate was bioengineering?
Yeah, exactly.
And then, was that straight then with Eric Betzig, or was there something between that?
So yeah, between the bioengineering undergrad and the time with Betzig, I did a PhD at UC Berkeley doing biophysics. So the kind of common thread, I guess you could say, both from the bioengineering and the biophysics was kind of an interest in tool building. Very different kinds, but the sort of love of instrumentation really kind of took off as an undergraduate, and then I did more of that as a PhD student at Berkeley, and then with Eric Betzig in microscopy.
So your love for instrumentation Was that always microscopes?
So, there's always a link to imaging, I would say. So as an undergraduate, I played around with honeybees. So the guy that I worked for as an undergraduate, was actually in the chemistry department. He was an analytical chemist that had invented a pressure-sensitive paint that he had used to coat airfoils. So if you want to understand the pressure distribution on an airplane wing, he had actually marketed this paint to Boeing. And by the time I joined his lab, he was kind of getting close to retirement, but he had this crazy idea of using this paint to try and coat the surface of a honeybee wing. So the paint gave off a signal, a phosphorescent signal, that was inversely proportional to the amount of oxygen. So it was an oxygen sensor. And the idea is that when a honeybee flaps its wings, his dream was to try and see if you could actually measure that distribution of oxygen pressure using this paint. And so it was my job to kind of figure out how to put the paint on the wing of a honeybee and then image it. So not exactly microscopy, or sort of microscopy, but we weren't using microscopes to try and do this.
Did that work? Sure.
No. So it didn't work like we hoped on the honeybee, because the honeybee is just too fast. So it beats its wings on the order of hundreds of frames per second. And we just didn't have the signal to noise ratio we needed. But in the course of trying to do that, I learned a ton, and it really got me interested in research. And I actually built a very crude instrument, what we called the pressure-sensitive microphone. It was just a tube of PVC pipe with a film of this honeybee, of this polymer containing the paint that we put on the honeybee at one end of the pipe, and then a speaker at the other end. And so we would fire sound waves at one end of the pipe and then detect the response using the paint. So it wasn't like a microscope in any conventional way you think about it. You weren't looking at anything, but it sort of served the same purpose in being able to characterize the response of this thin film of phosphorescent paint in response to the sound waves.
So it's quite neat. So I guess even then, not fluorescence per se, but still the illumination of light from chemicals.
Exactly.
Which is done from there onwards as well. So it's kind of brought both those parts together quite nicely. So when was the first time you actually used a microscope properly?
So I don't know about properly, but the first time I ever used a microscope, I was probably a kid, and my parents bought me one of these cheap microscopes that I just, it had a bunch of kind of pre-built slides that I put on the microscope. And then I think there may have been some ability to kind of make my own slide, but it was very very basic, so I might have collected some leaves or something and tried to magnify those, and that was definitely fun. But the first time that I actually used a microscope properly would have been much later, probably as an undergraduate or possibly even as a graduate student, when I was trying to make my own microscopes. So there was a bit of a gap in there before I used a proper microscope.
So actually a question. So you actually spent a long time in the UK, if I'm correct.
I did. Yeah, so I was born in India, but then when I was 1 year old, my parents moved to the UK trying to get better jobs. And so they were both medical doctors, and they kind of trained in the UK. And we moved around a fair bit in the UK. But from 1 to 9, I actually grew up in the UK, in different towns in England.
So whereabouts?
So a lot of time in Birmingham, and then some time in Stoke-on-Trent, okay. Which I kind of remember fondly, and then moving over to the US.
Yeah, so I'm a Brummie as well. So for those who don't know what a Brummie is someone who is from Birmingham as a city, second biggest city in the UK. So actually, I am a Brummie, I guess, born north, went south. It was an interesting place years ago.
Oh yeah,
it's very. I go back now. It's a really multicultural, diverse, vibrant city. It's really
nice.
Reinvented itself. But I'm not so sure it was like that when I was a child. Certainly, I remember going in as a teenager into the city, and there was some places that were good. There was other places that you were not so good. I don't know what your memories are like of the city at the time.
Yeah, akin to yours in some ways. So I have kind of mixed emotions about Birmingham. I mean, like you've said, I'm sure it's much better now. But when I was there as a kid, some of my memories, unfortunately, were of other kids calling me Packy. as a school child. So that was kind of a rough time growing up there. One of the good things about sort of England in general and the educational system there is that I felt that I was way ahead of my peers when I came to the U.S. So the kind of educational system was great, but it was kind of a rough time growing up as a kid in parts of England for this reason.
Yeah, I can imagine areas that it would be like that, certainly. But certainly, there's always going to be areas, I guess, that are still not great. But actually, Birmingham as a whole is actually it's a really cool place to go now. So my parents still live near there, so I visit there. Don't often go into the city though, but it's quite an attraction now. People actually visit Birmingham. Go to Birmingham because they had to, whereas now they would actually choose to visit it.
That's awesome. So the kind of industrial feel is turned around. Yeah,
very much so. So what do you miss?
UK. Yeah, I mean, I miss going for walks in the countryside with my parents. I mean, that's something that we still did in the United States, but I just miss the kind of lovely English hedgerows and hedge mazes, and I miss parts of London. So I have an aunt in London, and we would sort of go there for a treat to visit her. I miss Trafalgar Square and Regent's Park and walking around that area as a kid. And I frankly miss my nannies. So the notion of like an English nanny is something that was, my parents both worked a lot when I was a kid, and so I had great nannies who taught me all sorts of things, as a child, and I miss all of that too. I have very fond memories of growing up in England as well.
Oh, that's good. And come on, you were in Birmingham for 9 years, or roughly 9 years. You must miss the chocolate.
I miss in general English chocolate and European chocolate compared to some of the crap that you get over here in the States. So I do miss that too.
Yeah, I just for you, Heath, look.
Oh, nice. Cadbury's.
Which is, of course, a Birmingham confectionery.
It's funny you say that. I actually remember walking by a Cadbury's factory, and it probably was in Birmingham. I have vague memories of this, yes.
Yeah, so Bournville, so that was probably 4 miles up the road from where we moved when I was about 6 to the south of Birmingham, and it was about 4 miles away from Bournville.
Yeah, and it's not that easy as you say to get that here. Yeah, to get that sort of chocolate here in the States.
Yeah, good milk chocolate. I love dark chocolate, but there's always a place for Cadbury's.
Yeah,
for sure. We started talking about earlier. So you went to America. You went through your PhD days, and then ended up at Janelia Research Campus, or Janelia Farm as it was then. What was that like? Because that's quite a different environment.
It is, yeah. I mean, I would say that for a postdoc, it was an amazing environment in the sense that you could really focus on your research. I mean, there were very few distractions, and funding was easy to come by at the HHMI Janelia Farm. So these were some of the good things. I think, one of the challenging things is that very sort of myopic view on microscopy and neuroscience meant that in some ways it was difficult to get a broader view as to what was going on. And that's one of the things that I like very much about the NIH, and that I miss, frankly, in a university setting. So at Janelia, the dominant kind of life form, let's say, is the postdoc and the PI, and that's great. But I do miss, in some ways, being around university campuses and the kind of broader exposure you get. But there's no question that, from my career, being at Janelia for 2.5 years was amazing. And some of that was Janelia, some of that was Palm and Betzig, and sort of being at the right place at the right time. So it was in some ways very lucky that I got into that, and it was just luck. I was finishing my PhD at Berkeley and wondering what to do for a postdoc, and I love microscopy. I saw many of my peers at Berkeley going to all of these kind of wonderful labs, but in some ways standard labs, right? So there's sort of this notion that as a postdoc you have to get into a good lab and do a good postdoc to get a good position. But frankly, I had no idea what I wanted to do when I was finishing my PhD. And when I was wondering about that, Betzig rolled through Berkeley, kind of an unknown. He had spent a decade plus basically in his living room, dreaming up microscopy ideas. And he himself had just gotten this job at Janelia Farm. And so he gave this talk on what would eventually become the precursor of the lattice light sheet microscope, lattice microscopy. And his talk kind of blew me away. He was a tool builder. He'd been out of the business for a decade, but he really wanted to build microscopes that could enable biology, and something about that spoke to me. So I remember speaking to my peers, sort of telling me, what the heck are you doing? This guy has been out of science for more than a decade. What is Janelia Farm, and why would you go there? So, this was a big risk at the time. He was in some ways kind of a no-name getting back into microscopy, and Janelia was also unproven at the time. I was one of the first 100 people to go to Janelia, but something about his talk really spoke to me, and I liked the idea of working in kind of a biological Bell Labs environment. And this was, for better or worse, it was the right move, because I worked very closely with him, and I, again, just luck, I happened to get into the Palm Storm business early. And I'm not doing that anymore. Like when I started at my own lab at NIH, I could kind of see the writing on the wall. I didn't want to keep doing that. But there's no question that this was luck favoring the prepared mind, and being able to take a risk, paid off in this venue. So we can talk more about that if you want, but I think it was the right move for me at the time.
I love the way you said you could see the writing on the wall for Palm and Storm. In what context? You're saying it's rubbish, God, it's all yesterday's work.
Yeah. So for 2.5 years with Betzig, I kind of lived and breathed Palm. I mean, that's all I did. And there was a ton of developmental work that had to be done on this technology. I was late to the party. Betzig and Xiaowei Zhuang and Sam Hess's papers had all come out before I joined Betzig's lab. But it was clear there was a lot of work that had to be done, developmental work, and I was fortunate to do all of that. At the same time, after doing my postdoc, I had done so much of that stuff that I was sick of it. And one of the things that drew me to the NIH is that the person that recruited me there and eventually gave me a job, Richard Liebman, he said when I joined, I don't want you to be doing the same thing in 5 years. And that was, aligned perfectly with where I saw myself, because I didn't want to be doing Palm Storm development in 5 years. And when I say I could see the writing on the wall, I meant that I could see, as I was doing my postdoc, and many other people kind of getting in to this field. And as a technology developer, I just didn't want to sort of be part of that bandwagon, which isn't to say that there wasn't and hasn't been fantastic development work in that area. I mean, after all, it won a Nobel Prize, but I just thought it would be easier if I could start to kind of do other things, in my career. And so that's what I meant. No diss on the wonderful developmental work that has been done by many other people in that area.
Too late. You've done it. You've dissed it.
Yeah, maybe I have. Yeah, a little bit. So that's sort of what I meant, and I just wanted to kind of move on to other things a little bit.
I think you're right there, because as you say, once it's developed, the big bangs happened, and it becomes a very crowded market. As
exactly.
Iterations and techniques to fill different niches, which are very needed, but maybe not so big an impact on the broader field. Whereas you've gone off, developed your own, and really moved into an area where you've made your own name. Certainly through the lattice light sheet and the algorithms being applied for that, for speeding it up. So how did you find setting up your own lab?
Intimidating and difficult. So I got some good advice when I was getting into starting my own lab, which is that you want to start small, and that the people you really hire in the beginning can make or break your lab. And so I really took that to heart. And in fact, when I started, by the way, I wasn't involved in any of the lattice light sheet work. That all came after me, but I was interested in light sheet microscopy. And so, I had just a few ideas. I wanted to kind of extend Palm. Some of the work that I did in Janelia, in fact, all of it was all limited to 2D. And I wanted to try and do 3-dimensional imaging and sort of, as you say, kind of make a name in that area. And so, there were a few ideas that I had when I started my own lab. I wanted to do 3D Palm. So that's one of the first projects that I did with my postdoc. But then I wanted to move on to other stuff, in 3D imaging. And so I knew that I wanted to do something in light sheet microscopy. And I was kind of interested in structured illumination microscopy as well. But I had only a handful of projects when I started, and I really only had a handful of people. I think I hired one post-bac, sort of similar to somebody who had an undergraduate degree and worked as a technician. And then I took my time hiring postdocs. For the first few years, I had just 2, and they were both excellent. So to answer your question, I mean, it was intimidating and difficult. And the way I kind of dealt with that is I tried to work on just very few ideas and invest a lot of my own energy in making those work at the beginning, so that I kind of had a foothold when I started my own lab. And I feel like that really was the right strategy for me, because having a bit of success builds confidence. And, it kind of gave me the confidence to know that I could do this by myself and, with the help of my lab. So that's sort of honestly how I felt in the beginning. And there's one story that I remember that when I just came in, my lab space wasn't ready. And in fact, the NIH is great, but one I won't say failing, but one issue is, and maybe this is characteristic of people everywhere when they start their labs, but for 9 months, I was in a conference room where I would order equipment and it would land in the conference room, and a surprising amount of science got done. So we had an optical table, and I don't know if we could even float the table, but we started to build stuff on that table and at least hammer out some of the microscopes. But the kind of one moment that I remember, so I came in on my first day into this conference room, and I think I just had a laptop that had been ordered for me and some Thorlabs boxes. And I had a desk that I had pillaged from some other surplus. And I sat down, and I sat down with my laptop, and my deputy director walked in with a laptop, and he gave me the laptop and told me how to connect to the internet. And he said, "Well, I'm sure you must be very busy now." And he left me to it. And I started to wonder, is this the right thing? Like, what am I doing? Like sitting in a room, essentially an empty room, with this laptop and some Thorlabs boxes. And I was wondering what the heck I was doing. So that's how I started my lab. I started without clean water and without any microscopes at all of which I built. But I was fortunate to be in a very supportive environment, and I made a point of emailing different PIs in the Institute and having lunch with a different person every day for the first few months to kind of, start to know what was going on at NIH. And so I just kind of tackled the uncertainty head on, but yeah, there's this fear, as a new PI, and in some sense, aspects of that fear never really go away. So to all new PIs, I would just say embrace the uncertainty as best as you can and know that you're not alone. And it gets easier if you can stick with it, because in the beginning, you're doing everything by yourself.
So you're in the lab, obviously, as well, quite a lot at the start as well. So has that changed? Are you still in the lab as much as you were, or are you now more office bound?
Yeah, so I am more office bound, but I do stay very close to the research. And in fact, when my lab did get built, one thing that I insisted upon was that my office is kind of in the center of my lab. So if you were to come visit, which I hope you do at some point the next time you can, you'd see that my lab is kind of arranged with optics labs around the office, and my postdoc office is kind of right next to mine. So I am much less like at the optical bench, because as my lab has grown, I spend a lot more time managing my people, but I make a point of trying to speak to everybody in my lab at least once a day, at least just to find out how things are going. And I really want to know how things are going, and in particular, how things are failing. I'm really interested in knowing that as a PI, and I like to stay very close to the research, but it has changed. So in the beginning, I was kind of building the hardware until my postdocs told me that I shouldn't do that, that they were better at it than I was, which is true. And now I spend more of my time writing papers and talking to people about their projects and strategizing about optical design. Every once in a while, I'll write some part of a piece of software, but it changes, or it has changed for me.
So you're asking your team about how they are or how the lab's going. You also I certainly find finding out what's going on in their personal lives or being engaged at that as well is really important. It's important for me, certainly, to know what's going on and for them to have an outlet as well, because they don't always have easy outlets out, because a lot of them are transient. They come in from different places. They haven't necessarily got a social circle. So, yeah, I guess you met at the start, I bet you would possibly even go to the bar or eating out with them because you'd have landed there, your team. But that must have changed as well. You have a family now.
Yeah, it has changed. So, one thing that hasn't changed is, like you said, going out for a meal, I try and make myself available for lunch every day with my lab, because I do think that's one time, they don't always want to eat lunch with me, but at least I have to eat lunch too, right, in the lab. And so that's one time when I'm accessible. But you're right, it's changed. And, more recently it's changed, like you said, because I have a family. I have a daughter who's 1.5 years old, and that has kind of sucked. There we go. Yeah, there she is.
Very cute, by the way. So it's a picture.
Thank you. Yeah. That's Amelie. a few months ago now. So maybe a year and a few months there in that picture. And yeah, that she, for better or for worse, has kind of sucked all the energy out of my life after the science. It's kind of a full-time job outside of science, right? As being a dad, as I'm sure all the dads know who are listening to this. And so there is less time for doing things with the lab, for example, afterwards. I like to climb, and every once in a while I can go climbing with people in the lab, or even we have a climbing group. There we go. Yeah, thank you. Outside the lab, other postdocs and other PIs at the NIH. So that's one outlet for me outside of the lab and outside of my family. But all of that has been made more difficult right now anyway by my daughter, because I like to, as much as possible, share the duty with my wife, even though it's impossible to share. I can never replace the mom part of my wife, right? But I try when I'm home and in the morning somewhat.
So you say that, but is this not your daughter on a climbing wall? So you're not trying to combine everything here?
Yeah, I would love to get her on a climbing wall as soon as she's able. And now she's kind of running around, but I like to. This is in a playground near our house, nearby, where there's a mini kind of climbing wall. And actually, she's shown that she likes to climb even in our apartment. So she's climbing on all kinds of things, like on our furniture, and then she also likes to climb like on the grates that we use to separate her from where we are occasionally, like the kitchen.
Yeah.
And she will be a climber when she grows up.
It's fun times. It does make finding time to socialize with your team much more difficult. Which changes the dynamics a little, but and actually as your team mature as well, they find themselves in a similar position.
Yeah, I mean, I think one of the biggest changes for me with respect to the team dynamic is just appreciating people in my lab that have kids, what they have to do, right? I mean, that's something that you kind of understand as the abstract, the abstract, but at least for me, like having a kid myself really drove that home, right? It is not easy, I mean, to maintain any semblance of work-life balance, like with your family. And so I do have more respect for that, being a dad myself.
So, which is good. I mean, how large is your team now?
So in my lab in particular, there may be between 8 and 10 people, depending how you count. But then I also supervise a trans NIH imaging facility, which is kind of like a core facility with just a few staff scientists. And the idea is that they try and deploy advanced instruments like home-built instruments that people in my lab and other PIs at NIH build. People in this core facility try and make that more accessible. So there are 3 people in that facility as well. So when you count them, it's more like 13 people.
And so those 3 will probably have a very different mindset over the postdocs that are doing the research side, because it's no lesser a job technically, but it's a very different mindset, because now I guess they're interacting with lots of biologists and trying to share and spread their expertise and use their expertise to develop lots of applications, rather than specializing in one area and just building that one bespoke. How do you find the differences in personalities between those 2?
Yeah, I mean, I think you're absolutely right? So there's, on the one hand, the very technical diving into, in my case, like what makes a microscope better. So thinking carefully about like what breaks microscopes, because you will never find a microscope that is not defeated by a sample. So I think the interaction with biologists is critical for that aspect. Also, it feeds back into the technical aspects. And in fact, I love it when biologists come to use the microscopes like in my lab. As you say, though, like a core facility manager is going to be more interested maybe with making a biological experiment work. And I have immense respect for that, because I view this as kind of a continuum, right? I mean, you have your instrument developer, but siloing the instrument developer in a space where they never interact with biologists is just totally a mistake, right? Because then they invent something which may or may not be useful. And for me, like building things that are useful is kind of the reason that I have a job, right? I'm lucky that I have time in my ivory tower where I can think about the physics of a microscope. But to me, if it's not used by a biologist in the end, I mean, it's kind of useless at the very end of the process. So you're right. Like the mindset is different in a core facility, or even in this kind of advanced core facility where they're trying to disseminate the technology. They really have to be looking at what makes something useful and how to make it more useful. And I just think that's so useful. It's so important for the instrument developer to kind of see and to interact with. It is a bit of a different mindset, though.
Yeah, I guess one nice bit is you've got a team that is developing impact and another team that is delivering the impact.
Yeah.
So it's really quite nice to have both set up there. And you're absolutely right, those new technologies need support because they're not off-the-shelf products at that point.
And some of them may never be off the shelf, right? We've been fortunate that we've commercialized some things at NIH, but there are going to be other technologies that are just too difficult to do that, or maybe there's not enough of a market.
Yeah, and you see quite a lot of startups who actually say that you're right. They siloed into a room. They think they know what they're doing from an engineer perspective. They develop something, but at the end, it's not that useful to the end user. They've moved away from what the end user and how they would engage with it. Because trust me, biologists are very different animals compared to other science spaces. Likewise, a chemist is different to a physicist and so forth. And it's quite difficult, I think, for them to get an appreciation of that. Just go back, we started talking about your first publication as well. Not your first, your latest publication. But what is your favourite publication of all time that you've authored?
I don't know if I would say that I have a favorite, but there are maybe a couple that stand out. I mean, one would have to be my first paper as a graduate student, which was rejected 3 times before it was accepted, and I think that was a valuable learning experience for me for some of the hassles and difficulty of being an academic. I mean, that feature or downside hasn't gone away. My papers are still rejected all the time. But that was kind of a landmark thing, right? As a first author, getting my first paper published, and that paper was a bit ahead of its time, but actually is being cited more. It was on force sensing, making a molecular force sensor using FRET. So that was kind of a favorite just because it was my first. And then, a couple of the early papers from my lab too, right? That ended up kind of laying the groundwork, like the DICE-BIM or the InstantSim papers, are kind of, I would consider them important foundational papers from my lab because they built a solid foundation for which other papers kind of landed on top. And again, those papers were published with just a handful of people in the lab, so they're special for that reason.
So it was interesting. The first one, you said that one of your favorite, that it was ahead of its time when you published it. So it doesn't gather many citations early on if it's ahead of its time generally, and it takes time, and then that momentum grows, and then it does become more and more published. But if you're reviewing, if you were being reviewed, they're going to be looking at your publications, and citations are naturally one of the things they quite often look at. I presume it's the same with yourself. So how do you cope with that? Saying, well, it is great work, and now you can look back 10 years ago or more and say, look, it really was fantastic. And yet at the time, you could be getting heat for it not having the citations or the publications not having the impact, just because by the very nature, technology takes time to be adopted. And, and then actually published, you're talking, as you said, 5 years sometimes to get it to publication. So it's quite...
Yes, I think you're hitting on one of the most difficult things we have to deal with in academic science, which is measuring impact and papers and fundamentally, I think this arises from the timescale issue that you pointed out, right? That measuring what somebody's work is worth is something that takes time. It takes time for that to have an impact and to be picked up by other people and frankly used by other scientists, right? And this is very difficult because promotions and hiring somebody as a PI, I mean, what do they have to look at? Somebody once told me that, like these measures of H-index and citation count and where you publish ultimately, have poor correlation or can have poor correlation with the quality of a scientist, but scientists like to count. And that's the problem, right? In a finite time, how do you measure this? I mean, in a perfect world, you would read people's papers, you would talk to their references, but the problem is that the reviewers have only finite time. And so how do you reconcile these issues? And I think there's no perfect answer, right? I mean, the advocates of the kind of reading the science would say, well, what are you talking about? Of course you should read every paper. Of course you shouldn't pay attention to where it's published. And that, being on the other side of it as a reviewer, yes, you should do those things, but it's extraordinarily hard as a reviewer, right? If you're looking at 2 candidates, one who has, many more citations and many more papers in high impact journal, it's extraordinarily difficult to do the right thing, let's say, right? So I just want to acknowledge this is a tension that you face at every level of your career, right? It's just hard. There is a pyramid in how you judge scientists, and we all just have to be conscious, right, of these biases that are baked into the system, including the citations, as you mentioned. I mean, I don't have a perfect answer. I mean, when I try and get my postdocs a job, right? I mean, as an academic, you have a frank conversation and you say that the chance of getting to that one academic job is vanishingly small. It's just hard. And if you want to play that game, of course we will try and publish a paper in the best journal we can for you. I mean, one of the things I try and do is I relinquish corresponding authorship always to the first author on my papers. That's a small thing I can do, right? Because credit naturally flows upwards, right? But of course, the people that do the work are the people that need the credit. And it's hard in academia, right, to acknowledge the work that is being done by the people that actually do the work.
Yeah, I think what's sad is I think many realize and appreciate what you're saying, and yet everyone falls back to the status quo of going back to those citations and stuff. I think sometimes it's vital to publish. That is without question. Even if it's not in a top-ranked journal, it is. You have to show output. You have to share what you haven't learned or what you've learned that hasn't worked. Even you need to get that out there somehow, because we are being paid to do that. Yeah,
and finite resources, right? I mean, this is why I think publishing in peer-reviewed journals is important for the same reason, right? I mean, despite the flaws of peer review, I mean, there's something about it that is, over time inherently error correcting, right? I mean,
yeah. So moving on, it's a very serious, almost a depressing subject, really, because we're not going to change the world on it. So I'm going to ask you some quick fire questions.
Please.
Okay, so it's one or the other, as quick as you can. So, tidy or messy?
Messy.
Yeah, I can tell by the whiteboard behind you. Design over or function?
Function.
Soccer or American football?
Soccer.
Oh, good man. You'd be there. That's absolutely right. Baseball or soccer?
Soccer. I just want to say that baseball is boring. I mean, I think everybody acknowledges that baseball is boring. Even the baseball players think it's boring. If you look at them, they're chewing gum as they're playing, or tobacco.
You've probably just offended loads of people, but
yeah, maybe, yeah.
It's not my.
It doesn't mean it's not fun to have a beer and, I don't know, eat a snack in the bleachers, but it is boring.
Why, John, saying that, I quite like cricket.
There you go.
So different. It's a very technical game, is cricket. It's very tactical, so that's good from that side. Thinking of not my cup of tea or coffee?
Coffee.
Pizza or burger?
Pizza.
Indian or Chinese?
Indian, but it's tough. I like Chinese food a lot too.
Well, what's it like over in America? Because UK is brilliant for Indian restaurants, and Chinese are pretty good. Go to mainland Europe, really not quite the same. I mean, UK does exceptionally well.
Yeah. So I would say it's a strong function of where you happen to live. We're very lucky that the NIH and its surrounding area is home to many, many immigrants, which is a wonderful thing, including Chinese. And so the Chinese restaurants around NIH are fantastic. I live in DC, where there are also good restaurants, but it can be somewhat harder to find kind of authentic food, authentic Chinese food, and same with Indian food.
Yeah, so actually I'm with you with it, with pizza, Indian, coffee. Well, yeah, definitely.
Oh, nice, good man.
Coffee, definitely throughout it. So perfect answers. Car or bike?
Say again?
Car or bike?
Oh, I prefer to walk when I can. I'm using my car now because of COVID to drive to NIH. And I admire people that cycle and bike. I wish that I could get more into it. But given the choice, I would prefer to walk over either of those. Yeah.
That's fair enough. Book or TV?
Book.
UK or US?
Ooh, US is having a tough time right now. But I'm a US citizen, so I'm going to have to go with US.
Yeah, boo. No, I'm teasing. So you're into books. So that was a very unequivocal, definitely book. So what are you reading at the moment?
Right now, I'm reading a book that I would by an author that I would totally recommend. A very thoughtful sci-fi author called Ted Chiang, and one of his short stories has been made into a movie called Arrival, which was a 2016 movie, which is a fantastic movie about aliens arriving, and it's not actually about aliens, but so I like reading sci-fi, but I also like reading books about science and books about big things that happen in science. Like molecular biology or Feynman. So I like both science fiction and nonfiction.
Okay. Do you get much time to do much extracurricular reading?
Usually when the baby goes to sleep at around 8 o'clock, I have a few hours where I'm either doing more research work, science work, or I have time to read.
Yeah. And how do you find balancing that work-life side of things?
I think I've just kind of come to kind of accept it. I mean, in fact, I can't even remember what the heck I did before I had my baby. I mean, I sometimes wonder what the hell I did with all of my time. I don't know. Yeah, I mean, I balance it as best as I can. I mean, gone are the days when I could easily go to the lab on the weekends. I mean, that's pretty rare. I would say that my work has transitioned to more reading papers and writing an email when I'm back home. It's just hard, it's hard to do it. I mean, especially when our daughter was born, I was tired all the time. And now that her hours are more normal, it's easier for me. I can snatch a few hours after she's gone to bed, whether it's reading or watching the occasional TV show or doing more work, catching up at work. But it's difficult. I would say that sleep is the predominant thing that is difficult. So that's what I find that gets sacrificed in favor of work-life balance.
Yeah. So actually, just thinking about the current time, so COVID-19, the lockdown, I know you were locked down as well. How did you find the lockdown? How did that affect your work-life balance? Was it good, bad, indifferent?
For me, in some ways, the work-life balance hasn't changed all that much because of COVID, because I was writing papers and I got reviewed at NIH virtually. So the people that have really suffered on the work end are unfortunately the experimentalists in my lab, right? Those guys have been, champions of trying to milk existing data sets that they can work on remotely. But the time has come for them where they're really feeling the pinch of not being able to do experiments. As far as work-life balance, I'm trying to find the silver lining in being able to spend more time with my daughter, right? I mean, this is kind of a wonderful time because I can go for a walk with her to the dog park. She loves dogs right now in a way that I wouldn't have been able to do with a regular lab schedule. So there is some silver lining in spite of the COVID. I mean, it's occasionally difficult to balance the time with my wife because our office is our bedroom. So she has a desk and I have a bed and her rocker chair that she used when our baby was small. So that part of it is kind of a little bit uncomfortable. And I actually do find myself missing coming into the office and the lab.
Which at least you're in there today.
That's true. Yeah.
Not so bad on that side.
Yeah.
So that's a difficulty in balancing that, and especially with lockdown and having that space. But there's always a time that's very difficult in someone's career. You're still very young, but hugely successful. But you must have had difficult periods. So what have you found? What's been the most challenging time that you've had to overcome today? I
think, so two times come to mind. One as a graduate student when I kind of went through this transition of learning that, at the end of the day, I'm responsible for everything in my PhD. And maybe most people that have that do PhDs have some period of intense misery in their PhD. Mine was realizing that my advisor was just going to leave me to it. So I published a paper, on this force sensor idea early, and then I wanted to apply it to live cells. And I realized I had this sort of dawning realization that what I did to make this force sensor was not going to work in living cells. And my advisor was not going to help me to do this. And he even said as much. He said that his job was to kind of make me transition, into basically doing everything myself. And, I thank him now, but it was difficult to hear at the time. So that was the closest that I came to kind of an existential crisis. And, in the abstract, I sort of knew, right, that was what a PhD was about. You go to reading about science, actually really doing the science yourself, even if you fail. at doing it. And there were lots of failures, during that time. So that was difficult. And I got through it. Yeah.
So what sort of supervisor are you then?
So what I would say is that I try and at least right now, I try and let people have their own failures, but I am kind of obsessed with failure because particularly for the postdocs, this is their career on the line, right? So I want to know what the problems are so that I can help them attack it, right? Whether it's finding a plan B or reframing a paper or what their research is. So, I would say that I'm highly hands-on in the sense that I want to know the details, but I also want my postdocs to get the experience of building things themselves. I mean, where I'm not so good at this is the writing, because it's very difficult for me to not commandeer the writing of a paper, even now. I have a tendency to start writing drafts, well before we have all of the data, and maybe that's something I need to work on as a PI. But I also want to make sure that my postdocs and the few graduate students that I have this experience of failing a little bit. I think that's so important if you do your own science. And I've supervised the gamut of people that are highly independent and they don't want my input at all, to people on the other end where they need more of me. And I think that's one of the most difficult things as a PI. And that kind of leads me into the second most difficult period, which is at the end of my postdoc wondering what to do. I mean, I was a little bit burned out after my postdoc. After doing all this POM, I was on the one hand fortunate that there were many institutes that wanted somebody that did POM, but then I was in the position of not being wanting to be their super resolution person, wanting to do something else. And I also explored being part of a company, so I explored a few startups at the end of my postdoc. And what finally convinced me was a conversation I had with somebody who said, why don't you just try it, and see, how this PI thing would go, and see if you like it. And if it doesn't work, you can go do something else. But that was also kind of like a difficult time. And, as we said at the beginning of our conversation, the fear, right, of being able to kind of do it, be a PI, that was, also something, maybe I shouldn't be complaining, right? Because, I also have the luxury of being able to get a job and be a PI. That's such a fortunate thing, right, in science.
Yeah. But you made a success of it. Well and truly.
Yeah, somehow. Yeah.
Do you still have a burning issue to maybe try being in a company one day?
Not right now. Every once in a while, what gives me pause about your question is that I worry about ideas, about having good ideas. And, I like to do things that are a little bit off the beaten path if I can, and I like to do things that at least I feel have some chance of having an impact. And my fear, I guess, would be regressing to some mean thing where lots of other people are doing the same thing that I'm thinking about. So I worry about having good ideas. But every time I think about running out of ideas, something comes up, right? And the latest thing is this massive playground, which is deep learning, right? Which I'm learning a lot about myself. This kind of old technology that has resurged. And right now it seems like there's an infinity of things one could do with that, with microscopy, right? If as a microscopist, if you know the limitations of your microscope, and if you have a healthy skepticism about neural networks and deep learning, the world is your oyster, right? Because you can combine these things in ways that you wouldn't have thought possible a decade ago. So that's my current playground. I'm very interested in knowing where these technologies break and in seeing if we can make them better.
So another good point that you raise is 10 years ago this wouldn't have been possible. And I think there's a lot of things to be revisited. People have had great
absolutely
looked at it and it didn't go anywhere, so they've put it to bed. And in some cases they've lost it. They've put it under the bed, a mattress, and it's gone. And there's a lot of good ideas that could be easily brought back to the table and are now possible. I'm still not convinced that you can still paint a bee's wing and see the oxygen changes.
Me too.
Our sensitivities have improved, the speed has improved, but I've still got my doubts about that one. But again, it's things like that suddenly are now possible, or potentially now possible.
Yeah, exactly. And so my advice to all the scientists are listening to is, if you don't already, write down your ideas. Because even if you never look at your lab notebook, the action of, at least for me, writing the idea helps it stick. And as you say, there have been times, a few times that I can think of in my career, my admittedly short career, where an idea that I had a few years ago is which wasn't feasible then, and would have been like a junky idea, has come back for exactly the reason you say, Peter. I mean, we're kind of in this unprecedented time where technology is improving all the time, right? So something can be possible in one area that makes it possible, an idea in another area that wouldn't have been feasible a few years ago. So it's good to pay attention to that. Absolutely.
Which may be actually one of the first things you said when you started your job was to go and have lunch with all the different academic leads, because it's important to have those contacts, because they will be aware of possibilities or developments that you won't be. And it's bringing that together. I say your latest publication, it's got expertise from all over the world coming together.
Yes.
We can't do it all alone.
Yeah, exactly. Nobody has all the answers all the time. Yeah,
No,
we can't do it alone.
Okay, talking of answers, another picture which you sent, which is intriguing. I presume you are the person in the middle here?
Yes, exactly. That was in Iceland. So Iceland is a fantastic country. I mean, I would highly urge everybody to visit if you have the chance when you can at some point. But one of the amazing things about it is that it's kind of geothermal. And so they have all of these vents and geysers. In fact, the word geyser came from Iceland. So this is like in one of these areas where it was very cold, I think, outside, but there was hot air steaming from the ground in like a geothermal energy park in Iceland. And so I was just standing in the middle of that rising hot air as it came off from a fissure in the ground.
So did you do a lot of traveling, or was it a lot of traveling obviously up until now?
Oh, yes, I love to travel. I've been to close to, I lost count, maybe 40 plus countries. So I love to go and see the world. And this was one of the vacations a couple of years before we had our daughter that my wife and I took, driving a car across Iceland, which you can actually do in about a week, given how small that country is and how good the roads are.
And this one?
This one was sort of our baby moon, right? It was a vacation right before my wife could no longer travel, in Acadia National Park in Maine, which is also definitely a recommendation. It's beautiful there. So this is on a little island called Mount Desert Island, and we're looking over woods into the ocean. Lots of other little islands.
That's fantastic. I travel a lot with work, but actually traveling outside of that, not so often actually. Quite often to the UK, and certainly this holiday we'll definitely be in the UK. We're not going outside.
Yeah,
just unnecessary. I think UK's got some great places.
Me too.
I'm not saying we're going to Birmingham though. I said it's good, but maybe it's not quite that good to go holiday there. That's for sure.
Not quite that good.
So, and you said you travelled across there in a week, but you also, when you took your job at Janelia, did you not? You drove your car across the country, didn't you? Which was a
yeah. So between my PhD and Janelia, I bought my car, which I still use today, a 2006 Prius, and I drove it across the country with my dad from Seattle, where my parents live, to Virginia, where Janelia is. But maybe an even more crazy story than that. So, like I said, I was burned out after my postdoc, and I needed a break before I started my PI position at NIH. And so I bought a car in Dresden, Europe, with some of my friends, scientist friends that I met in Woods Hole at a physiology course. By the way, side note, Woods Hole is an amazing place. Everybody should go and take courses at the MBL. But I bought a car in Dresden and drove it across Europe and Asia. The idea was to try and get to Mongolia. So over 3 months, approximately, I drove across many countries then as part of this so-called Mongol rally, which people can Google. And so I actually ended up getting out of flying back in Azerbaijan, but my friends drove further into Russia and Kazakhstan, and eventually sold the car in Russia and drove back and flew back from Russia. So that was quite a journey as well, and also a great thing to do sort of between careers, right? As you have these kind of periods of your time in life, right? I mean, I would highly recommend people take these breaks. It doesn't have to be driving across Europe and Asia, but it was a fantastic thing to do at the time.
Yeah, so you don't just drive your team, you drive across the US, you drive across Iceland, you drive into you just definitely a theme going through there. And you still got the same car.
I still have the 2006 car. Yeah, we don't have that many miles on it because we barely drive it.
Okay, so you drive. See, this doesn't figure. You drive all the way across a country or countries, and yet you hardly use
different car in Europe and Asia. That was a 1994 Opel Astra, which did surprisingly well across Europe and Asia. I think there was only one servicing we had to do when we broke the muffler of the car. Yeah.
So, just before we end, we've talked about where your background started, where you got to. Where are you heading? What's the big unmet need? What's the next big thing? Where should
So right now I'm focused a lot on adaptive optics. So I think it's sort of a crime that, most of us that we do when we do diffraction limited imaging with a spinning disc confocal, let's say, even, through a sample that is much more than one cell thick, we're not getting the full performance of our microscope because the sample screws up the performance as you go deep. And I don't think adaptive optics, or AO, as it's called, is cheap or robust enough to just apply. It hasn't really taken off. So I would like to try and contribute to that and see if I can make it more something one can just insert into a fluorescence microscope. I think there is gains to be had to just get diffraction limited imaging in thicker specimens. Even if you're not looking in something as thick as a mouse brain, I still think there is room to be had. And then sort of related is this area of deep learning, right? So I would like to see how far one can push that area in conjunction with microscopy. So to what extent can you improve the resolution of your microscope, and how much can you believe it as a result, right? If you have this ground truth data, let's say in a STED microscope or an expansion microscope, can you actually apply that to a wide field or a confocal or a SIM and boost the resolution, and how far can you go? These questions are really interesting to me because I have kind of a skeptical eye in, whenever I look at a computational reconstruction. So I'm kind of interested for my own lab to figure this out, right? Like, where are the breakpoints of these digital technologies? I think there's tremendous room and creativity to be had in merging these different kinds of microscopes. So that's one of the things that that I'm pursuing myself and my group. But like you say, I also like to look at ideas that are older, that are decades older in some cases, right? I mean, the astronomers have been doing adaptive optics in ground-based telescopes for a long time. So I think there may be more we can learn from that. And then, I'm also always interested in talking to probe developers. If somebody said the gain in the brain is mostly in the stain, right? So I think that's absolutely true. We have to pay attention to the kind of probe development efforts that are being done, because that really drives development in fluorescence microscopy as well. Yeah, so these are some of the things that I'm working on.
I guess they all go hand in hand, because you then back to sensitivity. If you can improve sensitivity or capture of photons, then the probes don't become so limiting. But if they improve, everything is a step. They all go together. And I think actually probably computers and computer speed has been the biggest enabler to be able to compute, to develop, to drive even the microscopes that are now.
Exactly. And I think, computing speed is getting faster and cheaper all the time, right? Whereas microscopy hardware is kind of fixed, or, it hasn't come down like so much, right? I mean, yeah.
And, do you know what? I've forgotten my last question. Darn it. What's your favorite technique currently?
Favorite technique? Well, I mean, I love light sheet microscopy and the kind of plethora of different implementations of it, right, that are all suited to different things. I mean, I think, one thing to remember in fluorescence microscopy is that there is no omniscient microscope, which is why it's such a playground, for a developer like me. Of course, the flip side of that, the caveat, is that anybody who tries to convince you that their microscope is the best for all samples is selling you snake oil. So that's kind of the cautionary note, right? I mean, that's what makes it so fun, I think, to work in this field, right?
Yeah, it's a very good point about there's no one solution to anything. Yeah. There really isn't, which is such a big market.
Pick the tool for the job, right? I mean, that's sort of a key thing to think about. Yeah.
That's food for thought. Can you work? Can there be a system that could be the magic tool? Can we have
I don't think so.
Just do everything. Be the best at every element. There's a challenge.
I would love to be proven wrong, but I don't think so.
No, but that's today. 10 years time, come back
Maybe.
on this question. Maybe there'll be something out there. Harry, you've been great to talk to.
No, thank you so much. It's been so fun. Yeah.
It's been brilliant, and good luck with the next big steps.
Thank you. Thanks so much.
And with your little ones, little steps.
Yes, true. Yeah. In fact, the little steps are probably the things that I think about the most right now. So, yeah.
So, Harry, thank you.
Thank you.
Much.
Thank you for listening to The Microscopists, a bite-sized bio podcast sponsored by Zeiss Microscopy. To view all audio and video recordings from this series, please visit bitesizebio.com/the-microscopists.